Here's problem 726. A baseball outfielder throws a baseball of mass 0.15 kilograms at a speed of 40 meters per second at an initial angle of 30 degrees. What is the kinetic energy of the baseball at the highest point of the trajectory? Well, let's consider that we've thrown this baseball with some initial velocity equal to 40 meters per second, but this is at an angle of 30 degrees, and the mass of this baseball is 0.15 kilograms. So as it goes through this trajectory, it'll reach a maximum height, and at that point the velocity will be equal to, or velocity at that height will be equal to 0. The velocity at that point in the x direction will be equal to the velocity it had initially in the x direction, and that would be equal to the component of our initial velocity in this x direction. So that's going to be equal to 40 times the cosine of 30 degrees, and that velocity in the x direction at that moment will be equal to 34.64 meters per second. So that indeed will be the velocity it has at the maximum height when it has 0 y velocity. Hence, the kinetic energy it has at that moment will be the kinetic energy it has in the x direction, which would be 1/2 the mass times the velocity in the x direction, which is constant throughout the whole motion actually, and that's going to be equal to 1/2 times 0.15 kilograms times 34.64 meters per second squared, and that is equal to 90 joules. So the kinetic energy it has at the maximum height is equal to the x kinetic energy it has throughout the motion, which is 90 joules. The kinetic energy it has vertically changes as it's going up. It starts off with its maximum value right at the start, and then it slows down as it reaches 0 at the maximum height. So at that moment, all the kinetic energy of the baseball at the highest point is its horizontal kinetic energy, which is indeed 90 joules throughout the motion.